Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 7 from the October 2021 International A-Level Pure Mathematics P4 exam. And this question here is about vectors. It says, with respect to a fixed origin O, the line L has equation R equals 4, 2, minus 3 plus lambda, negative 4, negative 3, 5, where lambda is a scalar constant. And the point A has position vector 9i minus 3j plus 2k. Given that x is a point on the line L nearest to A, find the coordinates of x and the shortest distance from A to L. Give your answer in the form root d, where d is an integer. Okay, so first thing, we have a vector equation of a line, which is made up of two parts. The first part tells you about how to get from the origin to the line, and the part that's multiplied by the scalar, which in this case is lambda, that part of the vector equation of the line tells you in which direction the line goes. Okay, so this is the direction part and this is the position vector part, and there's a point A which has position vector 9i minus 3j plus 2k. So position vector means from O to the point A, from the origin. So I like to write these in terms of column vectors like those are written. I don't like to write I, J, and K in my calculations because I find it's much easier to deal with them as column vectors. You have to keep writing these letters everywhere, and everything is organized straight away. Now, so when you have a line and a point, okay, you have a line and a point. Okay, so you have, say that's our line L. Okay, and just say this is the point A. Say this is the point A. X is the point on the line which is nearest to A. Okay, so the closest that a point can be to a line, okay, is when you can join that point to the line, okay, with a perpendicular line. So X must be a point on the line which is closest to A. Okay, so X is on the line and is closest to A, so it must be somewhere such that the line from A to X is perpendicular to the line L. So we know that A to X must be perpendicular to the line L. That's something that we know. If X is on the line such that it's the closest possible place to A to X must be perpendicular to the line L. So that's one thing that we're going to use in order to find the coordinates of X. Okay, so that's one point. And the other thing we're going to use is that X is on the line L. If X is on the line L, it will satisfy the equation of the line L. So those 2 points, those two bits of information will help us to find what the coordinates of X are. So X, let's call it X, Y, Z. And we know that to find the coordinates of X, we need to find the position vector of X. Let's say, for example, this is the origin. This is O. We know what O to A is. We need to find what O to X is. That's what we need to find. We need to find the vector from O to X. That will give us the coordinates of X. Okay, so we already know what O to A is. O to A is this vector here, 9, negative 3, and 2. We need to find out what O to X is. O to X is X, Y, and Z, I'll call it for now. And okay, that's what we need to find. Now I know that A to X is perpendicular to the line L, and X lies on line L. So let's use those two bits of information. So we know that first of all, X, which has coordinates X, Y, Z, lies on line L. So we can take the equation of line L, which is 4, 2, negative 3, plus lambda times, make sure we copy it down right, negative 4, negative 3, plus positive 5. Okay, so as if X lies on line L, there's going to be a value of lambda that takes us to X. So there's going to be a value of lambda for which this will be true. So from here we can form three equations in X, Y, and Z and lambda. So you have 4 minus 4 lambda is equal to X, and we have 2 minus 3 lambda. 2 minus 3 lambda is equal to Y. and we have negative 3 plus 5 lambda is equal to z. So those are three equations that we formed, okay, from the fact that the point x lies on the line L. Now the other fact we're going to use is that the vector from A to x is perpendicular to the line L. So first of all, we've got to find what A to x is. Now A to x is this vector here, which you can say is OX minus OA. So we can say A to x is equal to O to x minus O to A. Alright, so O to x, as we know, is the vector x, y, z. That's what we've called it. Minus O to A. The vector O to A is 9, negative 3, and 2. That's the point. 9, negative 3, and 2. Just make sure that we said that correct. Yep. So this will give us the vector x minus 9 and y plus 3 and z minus 2. So that's the vector A to x. And we know that A to x, as we said, is perpendicular to L. Therefore, the dot product is equal to 0. So we can say that the dot product is going to be given by x minus 9 times y plus 3 times z minus 2 multiplied by, now we need the direction part of the vector, the line L, which is this, negative 4, negative 3, and 5. So when I multiply this by the dot product, I have to get 0. That will give us 0. So this leads us to an equation. We're going to multiply x minus 9 by negative 4, so minus 4 times x minus 9. And then you're going to have plus 3 times y plus 3, so it's going to be minus 3 times y plus 3, and plus 5 times z minus 2. I know all of this has to equal 0, so let's expand and simplify this. You have negative 4x plus 36, negative 3y, negative 9, minus 9, plus 5z, and minus 10 equals 0. So we have minus 4x minus 3y plus 5z, and you have 36 minus 10, which is 26, 26 minus 9, which is plus 17, equals 0. That's 36 minus 9. Just make sure that's 27 minus 10, 17. Okay, so we can say that, if you want, we can say that that means 4x plus 3y minus 5z equals 17. Just make it a bit more neat than that. That's another equation here. So now we have these sets of equations that we can use. These are formed from the fact that the point lies on the line, and this is formed from the fact that the line and the point from A to X are, the line from A to X are perpendicular to each other. Okay, so now I need to combine these two sets of equations together, so I'll do that on the next page. Okay, so here we have the equations that we need. So we have to combine these together to find the value of lambda, for which our equation we can find therefore the point x, y, z. So what I can do now is I can replace the x in this equation with what x is equal to, which is 4 minus 4 lambda. And I can replace the y with 2 minus 3 lambda. And the z, I can replace it with minus 3 plus 5 lambda. And I can now have an equation with just lambda in it, and that will help me find the value of lambda, which will take us to the point x, y, z for my vector equation of the line. So we're going to have 16 minus 16 lambda plus 6 minus 9 lambda plus 15 minus 25 lambda is equal to 17. So let's see what we have. That's minus 25 minus another 25, which is minus 50 lambda. And we have 16 plus 6 plus 15, that's 32, sorry, that's 22, 32, 37, that's plus 37 is equal to 17. So if I do 37 minus 17, that's going to give me 20 is equal to, this is 50 lambda. So we can say lambda is equal to 2/5. Lambda is equal to 2/5. So now I can use that in the equation of our line, which I'm just going to bring across. Okay, so here we have the equation of the line, which now will take us to the right point. We know lambda is 2/5. So we can say 4/2 minus 3 plus 2/5 times minus 4 minus 3, 5. I could have actually just also put lambda in here and find x, y, and z. Same thing. That's exactly what's going to happen here. So you have r equals, you're going to have 4 plus 2/5 times minus 4. So 4 plus, it's going to be minus, that's going to be minus 4 over 5. Okay, I'll just work out that as in a minute. I have 2 minus 6 over 5. And that's going to be minus 8 over 5. 4 minus 8 over 5. 4 minus 8 over 5. 2 minus 6 over 5. And minus 3 plus 10 over 5. And that's going to give us our coordinates, or our position vector first for x. So you have 4, that's going to be 20 over 5 minus 8 over 5, which is 12 over 5. And you're going to have 10 over 5 minus 6 over 5, which is 4 over 5. And you have minus 15 over 5 plus 10 over 5, which is minus 5 over 5. Yeah, it's 3 plus 2 basically. Is that right? That's going to be 10 over 5. Yeah, that's just going to give us 2. That's going to give me minus 1 straight away. Okay. Overthinking there. So that means the coordinates of x are 12 over 5, 4 over 5, and negative 1. So there we have the answer to that part of the question, 7a, where we had to find the coordinates of the point P. That's A part 1. Now we've got to do part 2. Okay, so now we know that the vector from A to X is given by, we have to find the distance of the shortest distance from A to L, okay, which is the magnitude of AX. So we got to find the magnitude of AX. So the shortest distance from A to L is the magnitude of AX. Okay, and we know A to X is now given by this, well, we know O to X now, so we need to find what A to X is. Okay, and we kind of got vector for A to X is this. So we can say A to X is given by this vector, x minus 9, y plus 3, and z minus 2. So let me take that and put it on this side. Okay, so now for part 2, we need to find the magnitude of the vector from A to X. Okay, so we know that this is the vector from A to X. Okay, so this is the vector A to X, which is now going to be 12 over 5 minus 9 and 4 over 5 plus 3 and minus 1 minus 2. So this is 12 over 5 minus 45 over 5. Let me just do this in my calculator for getting a headache. 12 over 5 minus 9, which gives us minus 33 over 5. And you're going to have 4 over 5 plus 3. That gives us 19 over 5. And this gives us negative 3. Okay, so therefore the magnitude of A to X, which is the length that we need, is going to be the square root of, you're going to have 33 over 5 squared plus 19 over 5 squared plus 3 squared. Okay, so let's find what that is. So we have 19 over 5. Let's just do it like this. The square root of 33 over 5 squared plus 19 over 5 squared plus 3 squared. That gives us the square root of 67. And that's what we had to find, I think, in the form root d, where d is an integer. Okay, good. That's the answer to part d. So we can say d is equal to the square root of 67. Okay, so we use the fact we need to find the magnitude of the vector from a to x. All right, so there's the answer to part 2. And then part b says the point B is the image of A after reflection in the line L. Okay, so let's just take what we found. We found A to X. Okay, so that was we found what O to A was. We know what O to A was. We know what O to X is. Okay, this is X, and this is X, sorry, and this is A. Okay, and we know what A to X is. Now we got to find the position vector of B, which is here. Okay, the position vector of B is this vector from O to B. Okay, so what we can do is, if this is a reflection of A in the line X, then this and this line will be the same length. Okay, and it was like this is a continuation of the line AX. Okay, so what we can say is that the vector from O to B is going to be the vector from O to X plus the vector from X to B. O to X plus X to B. Okay, or we could say O to A plus 2 times A to B, same thing. Will still take us to B. So we know that O to X we found, and X to B is the same thing as A to X. Okay, so we can say O to B is the vector from O to X, which we found already, which is what we got when we got the position vector, which was this vector here. This was 12 over 5 4/5 and minus 1. 12 over 5 4/5 and minus 1. That's O to B. Okay, and we know that X to B is the same as A to X. And A to X was the vector we found over here. A to X is this vector here, which we found, which is minus 33 over 5, 19 over 5, and negative 3. Minus 33 over 5, 19 over 5, and negative 3. Let me just make sure of that. Yep, and that's the vector from A to X. So therefore we can say that the vector we're looking for, O to B, is equal to O to X, which is sorry, this is O to X here, not O to B. O to X, okay, is equal to O to X, which is 12, 5, 4 over 5, and negative 1, plus this vector, which is minus 33 over 5, 19 over 5, and negative 3. So we add them together. O to B is going to be 12 minus 33. Okay, all over 5. So 12 minus 33 gives you minus 21. So that's minus 21 over 5. And 4 over 5 plus 19 over 5, which is 23 over 5. And minus 1 minus 3, which is minus 4. So there's a vector from O to B. And that is a position vector of B. And there's the answer to part 2, or part B of the question. And we're done with this question. Okay, so for this last question, if B is the image of A after reflection in line L, then B will be the line AB is perpendicular to the line L, and B is the same distance from the line L as A is on the other side. So O to B would be the same as O to X plus X to B, because this A to X and X to B must be the same vector. Okay, so there's the answer for question number 7, which was a vectors question, a bit long but pretty straightforward. And the question, other questions from this paper can be found by clicking on this playlist that will appear somewhere in this area at the end of the video. Other questions about vectors from P4 can be found in the playlist that will appear somewhere over here. And you can subscribe to my channel by clicking this link. Thank you for watching and see you soon.